To find the probability that we select a point at random that lies in the shaded region of these figures, we're going to set up a fraction, and that fraction is going to be the area of the shaded region divided by the area, the total area of the figure. Setting up that fraction will help us find the probability. We'll divide that to get a decimal, and then multiply that decimal by 100 to get our percentage. So let's go ahead and actually find the total area first. That's usually the easier number to find, and it's sometimes needed to find the shaded area anyway. So my total figure in this case is a rectangle. It's the entire large figure. To find the area of a rectangle, you guys recall that that's 15 times 9, base times height. So that gets me a total area for the bottom of my fraction of 135. Now, to find the area of the shaded region, it's not just 9 times 3. 9 times 3 is actually the area of the unshaded region, that rectangle in the center. So what I'm going to need to do, my thinking is going to be to do the big rectangle and then subtract off the area of the small rectangle to find the area of that frame. We've done problems like that before. So I want to find the area of just that frame. So take the entire area, which is the big rectangle, which we already know that area is 135. That's why I found the total first, because sometimes we need that number to find the shaded area anyway. I'm going to subtract off the smaller rectangle, which is 9 times 3, base times height, which gets me 27. So once I subtract those, the entire thing's 135, but I don't want to include that 27 that's not shaded. That gets me an area of 108. So that is my shaded area. So I guess for my blank down here, like that's kind of the work that went in that second blank. But all I need to do is jump to the end here, so get 108. So that's my fraction. It probably can be simplified, but what I want to do is just express my answer as a percentage. So what I want you to do is divide that. So do 108 divided by 135. That'll get you the decimal, and that comes up to be 0.8 when you divide it. And then to change a decimal into a percentage, either multiply your number by 100, or remember, just move your decimal 2 spaces over and add zeros if you need to. So the probability that I end up in the shaded region is 80% in this figure. Don't forget that percent sign. Okay, let's try one more right now with a circle, and then we'll finish up with our last one on the next page. So once again, our thinking is going to be the shaded area over the total area for these figures. So let's do the total area first. I like to start there. So my total area this time is a circle, and I can see that I have the radius given to me as 10. So I'm going to set up the area of a circle as pi times the radius squared, so pi times 10 squared. And go ahead and get a calculator and just get an approximate answer. So 10 squared times 3.14 gets me a total area of approximately 314 for the larger circle. For the smaller circle this time, that's my shaded section. So in fact, this time there's no subtracting required. I can just find the area of that small circle just by using my area formula. So we just said, area is pi r squared, so pi times the, doesn't look like I have the radius. Even though it doesn't look like it, I can figure this out. So here's what I would challenge you to think. So go ahead and draw another segment straight across the figure like that. You guys know that that's going to have a length of 10, since that's just another diameter of the big circle. Well, if I put the center point down and consider that the center of the smaller circle, 10 is not only the diameter of the big circle, 10 is the radius of the big circle, 10 is also the diameter of the small circle, meaning those two little pieces right there need to be 5. So we can find out the radius even though it didn't look like we were given it. So the radius of the smaller circle is 5, so to find that area, again, let's just use a calculator and get an approximate answer. So 3.14 times 5 squared, I'll go ahead and plug that down in my fraction down here, so pi times 5 squared. That gets me an area of approximately 78.5. And then finally, to get the probability that I land in that section, if I pick a point at random, go ahead and divide that. That divides out to be about 0.25, and then multiply that number by 100, or just move your decimal 2 spaces over, and I get a probability of about 25%. So let's try one more together. Once again, I want to find the probability that I pick a point at random and it's in the shaded region. Well, even before I start this problem, I'm going to estimate that my probability is going to be fairly low. Since the shaded section looks like it's not a large part of this figure, I'm guessing my percentage, my probability should be low. So the total area, let's start there. So my overall shape this time is a circle. To find the area of a circle, I want to do pi times the radius squared. 8 is not the radius, 8's the diameter, so just watch out for that. I'll put the center point in for the circle, which then helps me see really easily. My radius is going to be 4. So that overall figure, total area is going to be pi times 4 squared. And I always like to find that first, because sometimes we need that number anyway. So using a calculator and getting an approximate answer, the total area for this figure is about 50.24. Next up, I need to find the area of that shaded region. Well, I'll tell you that in the center, that shape is a square. So I'll find the area of the square, but that is not the shaded area. The square is actually the unshaded area. So once again, my thinking needs to be to subtract. I'm going to find the area of the circle, which, good news, you already know it. And I'm going to subtract off the area of the square. Because once I do that, what's left over should just be those outer pieces, those shaded pieces. So that's what I want to find the area of to put in the top of my probability fraction. So the circle area, we already know that from starting with the total, is about 50.24. For the area of the square, I need to do find its area, so it's 5.66 times 5.66. So using a calculator to do that multiplication, I find the square's area is approximately, or I guess, well, exactly, if we're using those as exact numbers, my area of the square is 32.04. Now, once again, that's not the number that I put in the top of the fraction, since that is not the shaded area. I suppose there's a way we could do that. If we plug that in, we'd find the probability that we don't land in the shaded region, which could help me find out the probability that I do land in the shaded region, if you get what I'm saying. Instead, let's just go ahead and subtract. I think that's going to be easier for most people. So let's just take 50.24, subtract off the square, which is 32.04. That leaves me with 18.2 for the shaded section. So that's going to be the top of my fraction at the end. And once again, I'll divide that out first on my calculator to get about 0.362, and then multiply that number by 100 to get your percentage. It's about 36.2%. Notice that percentages can still have decimals in them. That's totally fine, and I do want you to round a little bit for that. So the probability that I land in the shaded section is about 36.2%, which is fairly low, as we predicted. The shaded section does not look like it's a big part of this figure.